Welcome to a lesson with Dr. Powell. Let's take a look at the basic graphs of trig functions. First, let's think about sine and cosine. So, um, and we're going to plot these in the following way, where the axis here represents the input of the function, so the angle, but we'll just notate it with an x. And that is that with the y. Even this x and y has nothing to do with the unit circle. This is now going to be the input, and we can do it in radians. And this will simply be the ratio, represent the ratio. Okay, so think about the sine. Sine represents the y value, and it's going to be very periodic because the y, as your angle changes, your y value goes back and forth. Y value starts at 0, builds up to 1, goes down to 0, goes to -1 for the y value, back to 0. And on a graph, you can even just kind of visualize the y value moving up and down and back up. But as you're moving on the angle this way, so to 1, down, back, up. So where this is at the middle at pi halves, this is at pi, that's at 0. So we get a nice graph. That's the sine function. Okay, so that's sine of x. All right, what about the cosine? Same idea, but for the x value. The x value starts at 1, goes to 0, and goes to 0, -1, and then it's kind of doing the same thing on a circle with the same ratio of angles. So it should just be a shift of this, because now my pen would just be going back and forth like this instead of up and down. But since the circle is symmetric and radians is symmetric around, it's just going to be a shift by pi halves even of this one. In fact, it's going to be just like this. It's just this one shifted to the left by pi halves. So that's the cosine, which represents the x coordinate as you're moving on the unit circle back and forth. So cosine of x looks like a wave. This one starts at 0, this one starts up here. So those are the basic graphs of sine and cosine. Okay, now let's think about what the basic graphs of the others are. First, let's start with secant and cosecant. Now, if you have the graph of sine, cosecant is just the reciprocal. Well, so just take the output, the y value, and take its reciprocal. What's the reciprocal of this is 1. The reciprocal of something less than 1 is a little bit more than 1. A little more reciprocal of 0 is like an infinite. So you basically get an asymptote right there. And you get these parabola type things coming up. And right here, it's all negative, so it's just going down. So if you can graph your sine, you can definitely graph your cosecant. Cosecant, though, this would just be a guiding line. You'd have to erase it because that's not part of the graph. And so your graph looks something like this for cosecant. Secant would be done the exact same way from the cosine graph. So I'm going to move on then to tangent and cotangent. So for tangent, let's think about slopes. Negative pi halves to pi halves. Negative pi halves is like down here, and pi halves is like right there. Think about slopes. Well, the slope here is infinite, slope there is infinite. So we can think of there as being an asymptote at those places. In the middle, the slope is, so at 0, the slope is 0. And you think then from 0, it builds up to that. And then from here, it goes down to that. That's the graph of tangent. And it repeats itself. It's periodic. And so forth in both directions. Now, What about for the cotangent? The cotangent is just going to be the reciprocal. So if you just take the reciprocal of this graph, notice that the asymptote places would change. The zeros would become asymptotes. This would then be reversing. See how this is increasing? Its reciprocal is going the opposite, would be decreasing, but it would still be positive. And so if I just draw it right on top, the cotangent would come down like this, be 0 here, and then it'd be negative. And since this is increasing, the cotangent will be decreasing, going down like that. And so we have that the cotangent will look something like this. So instead of going from negative pi halves to pi halves, you'd go from 0 to pi. And it would look something like this. Okay, and then going down. All right, maybe there's a little bit more flattening here, but you can get a little bit of an idea of how that graph works. So something like roughly, okay. And it's also, again, periodic. Thanks for watching.